So in this video, we're going to talk about how to solve cube root equations algebraically. So when you're working with cube root equations, always remember to isolate the cube root. So in the problem solving steps, we're going to start off by doing opposite operations to isolate the cube root, then cube both sides of the equation to undo the cube root, solve for the remaining variable, and then plug our solutions back in to check and make sure that they're correct. So let's try this problem. Let's solve for x. So notice that the cube root is already isolated in this problem. So we can undo it by raising both sides to the third power. So when we do that on the left side, that just leaves us with x, and then we have 5 cubed. 5 cubed you can do on your calculator by doing 5 and then pushing the caret button and then 3. That should give you x equals 125. So now let's try solving this problem for x. Notice that in this problem, the cube root is not isolated, so we're going to have to do some extra steps to get the cube root by itself. So I'm going to start off by moving away this minus 4. So when I do that, that leaves me with 2 times the cube root of x minus 1 equals negative 6. Now I need to divide both sides by 2 to get rid of that 2. And so that leaves me with the cubed root of x minus 1 equals negative 6 over 2, which is negative 3. So now finally the cube root is isolated, so we can undo it by raising both sides of the equation to the third power. So when we do that, we get on the left side x minus 1 equals negative 3 to the third, which once again you can do that on your calculator. Just do negative 3 caret 3, and that should give you negative 27. Now we can solve for x by adding 1 to both sides, and when we do that, we get x equals negative 26. So we can check that the solution does make our equation true by plugging it back in. So we get 2 times the cubed root of negative 26 minus 1 plus 4, and we're checking if that equals negative 2. So we get 2 times the cubed root of negative 27 plus 4, checking if it equals negative 2. And so that tells us that 2 times the cubed root of negative 27, so we have negative 3, and then plus 4 equals negative 2. 2 times negative 3 is negative 6, so we have negative 6 plus 4, which does in fact equal negative 2. So this is in fact the correct solution. So now let's try solving this problem for x. So we have the cube roots which are isolated on either side of our equation, right? So since they're alone, we can raise both sides to the third power. So when we do that, we get x plus 1 equals 2x. So now we can just solve this equation for x by collecting all the variables on one side of our problem. So we're going to subtract x from both sides. So that gives us 1 equals x. We can go ahead and check the solution by plugging it back in. So we have the cubed root of 1 plus 1 equals the cubed root of 2 times 1. And this is telling us that the cubed root of 2 does equal the cubed root of 2, which is in fact true. So x equals 1 is the correct solution. So now you can go ahead and pause the video and try this example on your own. So in this problem, the cubed root is already isolated, so we can go ahead and raise both sides of the equation to the third power. So when we do that, we get 3x minus 1 equals 8, and then solving for x gives us x equals 3. If you plug x equals 3 back into the equation, it does in fact prove the equation true. So now let's try this problem. So we once again have cube roots that are isolated on either side of our equal sign, so we can undo them by raising both sides to the third power. So when we do that, we get x squared plus x minus 14 equals x plus 50. So now we need to work on solving this equation. Well, notice that it is a quadratic. Remember, whenever we have quadratics, we want them to be in ax squared plus bx plus c equals 0 form. So we need to set this quadratic equal to 0. So we can do that by moving over the terms. So I'm going to start off by subtracting x. So when I do that, that gives me x squared minus 14 equals, and then the x and minus x cancel, so we have 50. And then now I can solve by subtracting 50 from both sides. So when I subtract 50 from both sides, that gives me x squared minus 64 equals 0. So now we need to work on solving the quadratic x squared minus 64 equals 0. So I'm going to remind you of the difference of two squares. which is a factoring property that we used, right? Difference of two squares. Remember that told me that whenever I had something that looked like a squared minus b squared, I could factor that as a plus b times a minus b. Well, notice I have x squared minus 64. So I can actually write that as x squared minus, and then 64, remember, is 8 squared. Okay, so when I factor this, I can write this as x plus 8 times x minus 8 equals 0, which I can now solve by setting each factor equal to 0. And when I do that, that gives me x equals negative 8 and x equals 8 as my two solutions. So I'm just going to now check these two solutions. I have the cubed root of x squared plus x minus 14 equals the cubed root of x plus 50. And so what I'm going to do is I'm going to test these two solutions and make sure that they do make my equation true. So I have x equals negative 8 and I have x equals 8. So if I plug in x equals negative 8, I get the cubed root of negative 8 squared minus 8 minus 14 equals the cubed root of negative 8 plus 50. So I have the cubed root of 64 minus 8 minus 14, and that equals the cubed root of negative 8 plus 50, which is 42. So that gives me the cubed root of 64 minus 8 minus 14, which is 42. So this is telling me that the cubed root of 42 equals the cubed root of 42, which is in fact true. So now let's try the other solution, which is x equals 8. So this is the cubed root of 8 squared plus 8 minus 14. And we're checking if that equals the cubed root of 8 plus 50. So we have the cubed root of 64 plus 8 minus 14 equals the cubed root of 58. So that is telling me that the cubed root of 64 plus 8 minus 14, which is 58, does in fact equal the cubed root of 58. So that is also true. So that means that x equals negative 8 and x equals 8 are both solutions to this equation. So now you can go ahead and pause the video and try this similar example on your own. So the cubed root is isolated on both sides of this equation, so we can go ahead and raise both sides to the third power. So when we do that, we get x squared plus 7x plus 5 equals 5x plus 40. And so we can work on this by setting this quadratic equal to 0. So we subtract 5x from both sides and then subtract 40, which gives us x squared plus 2x minus 35. So we need two factors of negative 35 that add up to 2. Since 2 is positive, I'm going to list out the factors of 35 and make the bigger factor positive. When I do that, the correct combination that I get is negative 5 and 7. So I have x minus 5 times x plus 7 equals 0. So when I solve this factored equation, I now get x equals 5 and x equals negative 7. So when I test these both values by plugging them back into the original equation, it does in fact show that both solutions are true. So I have two solutions, which are x equals 5 and x equals negative 7. So remember, to solve cube root equations, you're going to start off by isolating the cube root. You're going to then cube both sides of the equation, solve for the variable, and then check your solutions.